Okay, and we're back. We are in section 2.8 in the Unit 2B packet. Today we're going to graph some inequalities. We're going to be doing some graphs with shading. Now, for the warm-up, I do want to recap stuff we've done already. We have an equation. This is an absolute value equation. Remember the form that these guys are in. Remember that the vertex is HK. Remember, we say that H is opposite because it has a minus sign in front of it in the formula. So here, the vertex is, the H is 3, the K is 4. So plot our first point at 3, 4. This is going to form a V. The A here is an invisible 1 right after the equal sign. It's not showing anything, so invisible 1. So that means from the vertex, we want to go up 1 over 1 in both directions. And then we'll draw our V. And that's it. Pretty easy stuff. So that's absolute value. In example 2, we're going to graph a line. Notice this is in the form y equals mx plus b. So here the y-intercept is 5. And the slope is -2. So that's down 2 for every right 1. Remember, we want to get as many points as we can, spread it out, so our line looks more accurate. All right, not bad. And there it is. Okay, so the difference of what we learned already versus today is we reintroduce inequality symbols. Now, remember, some of these problems today are not going to be in the ready-to-graph form. They might not be in y equals mx plus b. Like these first 3 are, these are, but when we get here, we will need to get them in slope-intercept form. Now, when we are doing this, please remember the golden rule of inequalities. That says, when we divide or multiply both sides by a negative number, we must flip the sign. Actually, let's rephrase that. We must flip the inequality symbol. All right, let's look at that again. When we multiply, or when we divide or multiply both sides by a negative number, we must flip the inequality symbol. That'll come up later in the lesson, not right away. Okay, recall from inequalities. When do we use a dashed line? When they don't have the underlines, like right here, less than or greater than. When do we use a solid line? When you have the underlines, greater than or equal to, or less than or equal to. And then the shading. Whenever we see an inequality symbol, we got to do shading. So the first one, less than or equal to, is going to be below the line will the shading go. And then the other, for the greater thans, that'll be shading above the line. All right, so you'll hear me talking about those throughout today's lesson. Okay, so the first guy, graph the inequality. So the it's in slope-intercept, so I'm going to go ahead and the y-intercept is at -1. The slope is 3, so that's up 3, right 1. What kind of line is this going to be? I look at the greater than. That is a dashed line. And then for the shading is greater than, so that's above the line. So think of it like a roof, you know, a very steep roof, and we graph above that roof. All right, there it is. So if I were to ask you a side question like, hey, what are some solutions? You know, name a solution. You can name any point in the shaded region here, like -8, 3, or even 0, 0 is in there, or you know, -7, -5. They're all solutions. But dots on a dashed line, points on a dashed line, are not solutions. It's the dashed line just means it's like an invisible barrier. Okay, letter B. We got a y-intercept of 3. We have a slope of 4, so we're going to be going up 4 over 1. We can go in the reverse, down 4, left 1. And the symbol we're looking at has an underline, so that's a solid line. And the shading, it's less than, so this guy is going to be under or below the line. Again, if that sounds confusing, just think of this as a roof, and this would be under the roof. So, you know, is 0, 0 a solution? Yes. Is 10, 0 a solution? Yes. Is -5, 5 a solution? No. Is 0, 3? Would 0, 3 be a solution? In this problem, yes. 0, 3, where it's in lime green, would be a solution because it is on a solid line. That means it does count as a solution. Okay, this guy also in slope-intercept, I can graph right away. The y-intercept is -4. The slope is an invisible 1, so that's up 1, right 1. Up 1, right 1. We have an underline, so it's going to be a solid line. And less than or equal to, so I'm going to shade below the line. Okay, moving on. Letter D. Now, notice in this problem we are missing a variable. In each problem, such as D and E, whenever you have a missing variable, it's either going to be a horizontal or vertical line. If you recall from a unit or two ago, when we have x equals a number, that would make we would put it's actually telling us where to put our first point. And would it be like this? Would that be our graph? No, I don't give you anything like that where you're tracing over the axis. Absolutely not. This guy would be a vertical line. Now, it's not going to be solid. Always slow down and think about your dash and solid. There's no underline, so that guy is a dashed vertical line. Now, normally we say, is this shading above or below? But there is no above or below with a vertical line. So this is the only time that you are allowed to look at left versus right shading. only time, left versus right, is when you have a vertical line. So this would be less than, so it's kind of like the number line rule. Less than is to the left. Letter E, again, we have another problem with a missing variable. This guy is telling us where to put our first point. It's saying put it on the y-axis at 3. And again, would I give you a problem like this where you traced over an axis? No, absolutely not. It is going to be a horizontal line. And there's an underline I did check in the symbol. It's greater than or equal to, so solid line. And then the shading, there we're back to above and below, or below. This guy would be above because it's greater than. Okay, you do number 1. You're going to pause it here. And I want you to take a minute or two and try this in your packet. Now this guy is going to be more like A, B, and C above, because as you notice, it is in slope-intercept form, y equals mx plus b. So pause and try it out now. Okay, so your y-intercept here is -4. Your slope is 2/3, so that's up to right 3. Now the line here is going to be a dashed line. The symbol does not have an underline. And the shading is greater than, so that's going to be above the line. So again, if I were to ask you, what are some name a solution here, you could just name anything kind of in this shaded area. Don't name a point on the dashed line though. Okay, moving on. These are going to just get a little more difficult. Notice the space given to you. That's because these guys are not in slope-intercept form. So we need to get y by itself first before we graph. So here, I obviously would need to divide everything by 2. Now, do not flip the symbol here. The golden rule does not apply. We divided everything by a positive number, the 2. So don't flip the symbol. Remember, slopes we want to keep as fractions, so they're ready to graph here. You wouldn't graph a slope with decimals. All right, so we're ready to graph. This has a y-intercept of -4. It has a slope of up 5/2. 5/2, 5/2. The symbol, it's a greater than. There's no underline, so that's going to be a dashed line shade above for greater than. And done. Okay, next one. Got to get y by itself. It's in standard form. We don't want that. We want slope-intercept. So the first thing we should do is subtract 2x. Now, remember, when I say subtract 2x, you're not physically subtracting 2 from 6, okay? They're not like terms. You got to keep the -2x separate from the 6, not like terms. Now, again, notice it was on the left. The term was on the left side as a positive. Notice we moved it to the right side as a negative. When you move a term over, you got to switch the signs. Now we're going to divide by a positive 4. Reduce that to 4, so it would be 1/2. Now, the 6 over 4, that's a y-intercept, not a slope. So we can make a decimal there of 1.5. The reason we say a decimal of 1.5 is because that's our y-intercept, and 1.5 would be between 1 and 2. So it wouldn't make sense if it was a fraction like 6 over 4 or reduced to 3 over 2. You'd be thinking, where is that on the graph? But the slope, that's telling us how to move, so we keep the slope as a fraction. So we got a -1/2, so that's going to be down 1 for every right 2. Down 1, right 2. And the symbol was less than, so there's no underline, so that's going to be a dashed line shade below. And when you're doing your shading, please go to the edge of the graph, as you can see me doing. Okay, and the next one. This is actually finally our golden rule is gonna finally come up in this problem. We need to get y by itself. So first we're gonna subtract 3x. Then we need to divide by -4. This is where the golden rule comes in. We just divided everything by a negative number, so we need to flip the symbol. Negatives, double negatives cancel, so 3/4 x. That divides to get -6. So now we can graph this guy. We have a y-intercept of -6. And we have a slope of 3/4. So that's going to be up 3 for every right 4. And the symbol is less than, so there's no underline, so that's going to be a dashed line shade below for less than. So again, guys, when you're doing your homework, these have inequality symbols. Anytime you have inequality symbols, we need to see shading. Okay, I want you to try you do number 2 on your own. Take a couple minutes. You obviously need to get y by itself first and be very, very careful here. So pause now and take a couple minutes to try it on your own. Okay, now I'll show the work. The first thing you should have done was subtracted x. Now, the problem started out with a minus sign in front of the y, and you still have a minus sign in front of the y, which is a negative. That, in fact, is like saying it's -1y. So we get rid of that negative. We have to divide everything by -1. Does the golden rule happen here? Yes, it does. We divided everything by a negative, so we must flip the symbol. Right here, double negatives cancel, so that'll be a +1x. You could call it x. And then now we're ready to graph. The y-intercept is -4. The slope is 1, so up 1, right 1. And the sign inequality symbol is greater than, so that is a dashed line, shade, what did we say it was? Greater than, shade above. And that problem is finished. Hopefully you got it correct. Okay, moving on to the next page. Multi-step problem. Nothing, you should all be capable of this. It's just asking a few questions just as if I were to ask them. So the first problem, the first number said graph this. So the y-intercept is 3. The slope is 1/4. So up 1 for every right 4. And in the reverse, down 1, left 4. And then dotted or dashed or solid line. That's got the underline, so solid. Let's assume that's straight. Pretend that's a straight line. And less than, so shade below. Okay, so A is done. B asks or says, list one point that is a solution to the inequality. Obviously, you could have many answers here, like, say, 0, 0. 0, 0 could be a solution. It's in the shaded area. What about 3, 0? 3, 0 is actually right here on the solid line. Since it's solid, that counts. So 0, 3. 0, 3. What about 0? What about 0, 10? That would be up here, so I would not say 0, 10. All right, so any points in that shaded area or on the solid line are solutions. All right, so letter C, is the point 4, 4 a solution? So we zoom in, 4, 4 is actually right here. Yes, it is. Yes, because it's on the solid line. Yes, because it's on the solid line. Yes, because it's on the solid line. Okay, letter D. If the inequality was this guy instead, would 4, 4 be a solution? Well, if you notice, what's the difference between this versus the original? The only difference is the inequality symbol. So this guy would be a dashed line. So we're going to say the line would be dashed. The line would be dashed. So 4, 4 is not a solution. I apologize for my poor handwriting. It's tough with a stylus. All right, so the line would be dashed instead of solid. Therefore, 4, 4 would be on the dashed line, meaning it's not a solution. Okay, so let's go into graphing absolute value inequalities. So we touched up on the form, the equation back in the warm-up. But this time, instead of an equation, we're going to have shading, and we got to pay attention to our, above the line, dash versus solid line rules. The vertex, as I said earlier, is HK. And then the slope, we refer to that as the A. Okay, let's go ahead and graph. So the first one has remember H is opposite, so the vertex is -3, -5. -3, -5. The slope is not showing, so that's invisible 1, up 1 over 1, both directions to get that V formation. Now, solid or dashed. The symbol is greater than or equal to, the underline says that's got to be solid. And then the shading is above, so it'll be above this V. All right, there it is. And then the next one, the vertex is, and again, if I go too fast, just pause and rewind. The vertex, H is opposite, so -2. K is -3. -2, -3. The slope A is 1/2. So up 1, right 2. In both directions. Now, this line is going to be a dashed line. There is no underline, it's just a less than. And then for the shading, it's less than, so that's going to be below this V. And done. Okay, next one appears to be a you do, so I want you to pause this video, take a couple minutes, and try this on your own. Okay, let's see if you got it correct. The vertex here is 1, 4. 1, 4. The slope, A, is -2. Remember, when A is a negative, it opens downward. So it's down 2 for every right 1. And other direction, down 2, right 1. And then greater than or equal to, we have an underline, so that should be solid shade above. Solid shade above. I know it appears to go around, but remember this is technically above. Actually, let me back up a bit. Let me show you what people do that would not be correct. Where they only shade like right here. Do not treat this as a straight line. It's not a horizontal line. You got to get the whole thing above the entire upside down V. And done. Okay, next page. This is just the reverse of what we were doing. All you have to do here, it's actually really easy. You guys did this in Algebra 1. You just have to write an inequality from the graph. So real simple there. This is a straight line, so we're thinking slope-intercept, y equals mx plus b. So we go y is, now it's a dashed line shaded below, so that should be a less than. It's a negative slope, so negative, and then we go to points, and we'll go, okay, we got to put 2 points and then count the rise over run. This is down 1 over, whoa, what happened there? This is down 1 over 2, so negative 1/2. Please attach the x with the slope. It's very important. The x is the placeholder to tell you what the slope is. And then here, the y-intercept, let me show you in a different color. It's actually 4. If you look closely at the numbers on the y-axis, you got 2 and 6. So in between that would be 4. Letter B. Y is solid shade above, so greater than or equal to. We need a couple points for the slope, so say here and here, pretty far away. That's a negative, and it's going down 5 over 4. Attach the x with the slope, and then the y-intercept is right here at 3, plus 3. Letter C is a special case. It is not diagonal. So which one is this? Is this x equals a number or y equals a number? When it's a vertical line, it's x only. It's a dashed line. There is no above or below, as we referred to. We had a problem like this earlier, and when it was shaded, when it was a vertical line shaded to the left, this would be a less than. And then it crosses right here at the x-axis, so x is less than negative 1. All right, take a minute, pause the video, try this on your own. Okay, let's see if you got it correct. It's dashed line shade below, so y is less than. Points for the slope. It is a negative slope again. This guy looks like it's down 2 over 1, so we'll call that negative 2x. And then the y-intercept is right here. That's on the y-axis, crossing the y-axis at 1. There's your answer. Okay, that was it for the lesson. Have a good day.